Hey everybody, welcome back. In this video, we're going to look at a couple examples of for a sampling distribution of a sample proportion this time, right? So in our last video, we ended on this slide. We saw that the standard deviation of our sample proportions is going to be equal to the square root of our population proportion times 1 minus that population proportion over our sample size. And then the average of all of our sample proportions will just be equal to the population proportion that we started with. This is similar to the way that the average of all of our sample means was equal to the population mean that we started with, right, for our sampling distribution of sample means examples. And then our Z formula has changed a little bit, right? Now we're using our sample proportion instead of our sample mean. We're subtracting that from our population proportion. We're dividing that by that standard deviation of our sample proportions. So let's work an example of this. And first, we're going to look at some of those conditions that we saw from our last class as well. So if we go back a few slides, right, we saw these requirements that n times p had to be greater than or equal to 5, and that n times 1 minus p also needs to be greater than or equal to 5. So those are the conditions that we're going to check. For this problem, we're given up top here that the population proportion is 79%. We're told 79% of the world's population has brown eyes. So our P is equal to 0.79. It comes from the problem. And then we're asked if the sample size of 10 people meets our conditions. So what are the two conditions? We have n equals to 10. Well, we need n times p to be greater than or equal to 5. And we also need n times 1 minus p to be greater than or equal to 5 as well. So let's see if n times p is greater than or equal to 5. We have our n and our p, right? So let's take the 10, multiply that by 0.79. 10 times 0.79, we just move that decimal place over one spot, right? This is 7.9, and this is greater than 5. So that works. Now let's check this next condition, right? If n times 1 minus p is greater than or equal to 5, see if that condition holds. So we still have a sample size of 10, right, for this first example. But now we need to take 1 minus our population proportion of 0.79. 1 minus 0.79 is 0.21. So 210 times 0.29, I'm sorry, 0.21. Just again, move that decimal place over 1. This is 2.1, and this is less than 5, right? So we need both conditions to be met. This one is not. So we would show that work and say no. We could be more specific, n times 1 minus p, right, equals 2.9, which is less than 5. Okay, so now let's see. Oops. If our conditions are met for 50 people, do this in a slightly different color. Let's go just with green. So our P is still 0.79, but what's changed, right? Our sample size now is 50. So let's check this first condition in times P. 50 times 0.79. Let's see what this is equal to. Fifty times 0.79 is equal to 39.5. So that works, right? That is greater than 5. And let's do our sample size of 50 times 1 minus 0.79. We've already done this, right? We know that's 0.21. So 50 times 0.21 is going to be equal to 10.5. This is greater than 5, right? And just to be clear, this is also greater than 5. So this works as well. So we can say, yes, both conditions are met. All right, and then it wants us to draw the sampling distribution for a random sample size of 50 people. So this is going to be normally distributed, right? It will have its center at the population proportion, right, that we start with, which is 0.79. And we need to calculate the standard deviation of our sampling proportions, right? So this is a sampling distribution for a random sample size 50. So this is a distribution of all the possible sample proportions that we could obtain from a sample size of 50. If we were to continually sample 50 people from the world's population, right, from our starting population, and we were to continually sample 50 people over and over again, each sample, right, we wrote down, we took a p hat, which would be x over n. Our sample size is 50, and this would be, our x would be the number of people in our sample, right, with brown eyes. So we're calculating a sample proportion for the number of people who have brown eyes out of the 50 people that we sample over and over again. So the average of all those sample proportions will be equal to 0.79, which is our starting population proportion. And so our standard deviation of our p hats, which we need to finish this sketch, is going to be equal to p times 1 minus p over our sample size, right? And all of that we'll have to take the square root of, right? And this is great, right? We have our starting population proportion and our sample size of 50, so we can just plug all this in. So 0.79 times 1.79 over 50. We'll take the square root. This is 0.79 times 0.21, right? Divided by 50. And again, taking the square root. If I do 0.79 times 0.21, I get 0.1659, just doing this kind of step by step here, right? So I just did 0.79 times 0.21. We still have to divide that by 50. And then lastly, we'll still have to take the square root. So that 0.1659 divided by 50 is going to be equal to 0.003318. And we still have to take the square root. Don't forget about that. So finally, if we take the square root, we get 0.0577, we'll call it 0.576. Maybe we'll round it up to 0.058, right? From rounding it up. Okay, great. So our standard deviation of our p hat is 0.058. So now we can move over, right? One standard deviation to the right. We just need to add 0.058 to 0.79. And we get 0.848. Going 2 standard deviations over, we'll add another 0.058 to our 0.848, and we'll get 0.90. 0.906. And then lastly, if we go 3 standard deviations over, we add one more 0.058, and we get 0.964. Now, if we go down 1 standard deviation, we'll take our 0.79, subtract the 0.058, and we'll get 0.732. Subtract another 0.058, we'll get 0.674. And if we go 3 standard deviations below, we can subtract one more 0.058 and get 0.616. So this would be the sampling distribution of the sample proportion, right, for our world population of brown eyes with a population proportion of 79%, right? And then we would be able to use this distribution to answer questions, right, such as what's the probability that fewer than that a sample of 50 people would have have a sample proportion less than 0.70, right? We could find 0.70, and we'll do this in the next video. Some actual examples, right? 0.70. If we wanted the probability that a sample of 50 people had a sample proportion less than 0.70, right? We'd find the area under the curve here, and we'd be able to use our calculator or our z-table, right, to find this area under the curve, because those sample proportions are normally distributed. Okay, and we'll look at an example of that in the next video.